Okay, so let's go over the calculus homework, chapter 3, number 56. And in this one, I want to do this one just because a lot of people had trouble with this in class, thinking about what the derivative means here. So f of t, number of centimeters of rain that's fallen since midnight, t's in hours. Um, and then what we need to do is interpret all this stuff. So I think maybe a good way to start this problem is to actually think of like a plausible sort of graph for f. So let's try sketching one here. F of t versus time. And so this is midnight right here. Midnight, which is time equals 0. And then we've got, let's see, at f of 10, we're going to be at 3.1. And we'll just keep it going here. So we'll just pretend that this goes on for like, I don't know, 20 hours or so. So if you think about it, if it's number of centimeters of rain that's fallen since midnight, then it's accumulating. As time goes on, f can only get bigger or stay the same. It's not how much rain is falling at that time. It's how much rain has fallen since midnight. So you're like at when in part A it says f of 10 is 3.1. That means that at by 10 a.m. 3.1 total centimeters of rain have fallen. At midnight, nothing. You can't count anything yet because it's the amount of rain that's fallen since midnight. So at midnight, it's 0. You set it to 0. So if it's raining at midnight, though, maybe you start to increase how much rain you have. And like maybe here it tapers off and then it increases some more. And then let's say it's got to go through 3.1 there. Um, but again, it can only stay the same or increase, and that's it. So maybe it rains really hard right here, and then you taper off again, something like that. So this might be a type of graph that you could see for centimeters of rain that's fallen since midnight. So in part A here, when it says f of 10 equals 3.1, what you're saying is that at 10 a.m., and this we talked about already, at 10 a.m., 3.1 centimeters of rain have fallen since midnight. Right? That's, in fact, that's really all I'm doing. I'm basically just rewriting this. So, okay. So then part B says, what does f prime of 8 mean? Equals 0.4. What's that mean? So f prime 8, where is that? That maybe like about here, right? If that's 0.4, well, that's really saying df dt equals 0.4 when t is 8. And f is measured in centimeters, t is measured in hours. So that 0.4 is in centimeters per hour. So, and it's an instantaneous rate of the rain that's falling. So this is actually the rate at which rain is falling at t equals 8, which is 8 a.m. Right? It's an instantaneous rate of change of rain falling at 8 a.m. So that means the rate that rain is falling at 8. So f prime 11 equals 0. That's what we're told. So we know that the slope of f at t equals 11 equals 0. The whole thing is 0. So that means that on our graph, I'm going to edit this now. At 11, let's say 11's right here, it's got a 0 slope, right? Whoops, I forget that. Deletes it. Yeah, right there, it's got a 0 slope. Let's move 11 here and make it easier. Okay. So if it's got a 0 slope, let's exaggerate it. Let's say it's got a 0 slope for a while. Well, then that means right here, if we interpret this the same way that we interpreted B, 0 centimeters per hour, right? This is the rate at which rain is falling at, what is that, 11 a.m. Well, if I told you that 11 a.m., 0 centimeters of rain are coming down per hour, then it's pretty obvious that it's not raining, right? So this means it's not raining at 11. And then the last question is it possible to have f prime of t less than 0? And the answer to this is no. If you think about it, since f is how much total rain has fallen at any time, it either stays constant or it increases, right? Whoops, it doesn't decrease there. Sorry, that looks like it decreases. So it can only go up or it can go flat, but it can only do those two things. It can't go down, right? Well, f prime is the slope of f, and since f can only go up or stay flat, f prime can only be positive or 0. So no.